In this video, we're going to look at how one creates an Excel graph from experimental data from start to finish. The 10 steps outlined here are the steps that we'll use to take us from data all the way to the graph properly displayed in a Word document. Beginning now with the data, referring to the left-hand side, is the data that I've copied and pasted from the Logger Pro application. The columns should be labeled. The first column is time. The units is seconds. The next column over in this example is temperature. The units are degrees Celsius. Now the degree symbol can be approximated as a quick shortcut as a superscript lowercase o. So I'll make the superscript, and as you can see, it looks like a degree symbol. The next column over, which we have yet to create, is also going to be temperature, except in this case it's going to be in degrees Fahrenheit. I'll highlight those and boldface them and center them so they look nice. And while I'm at it, go ahead and turn that O into a superscript, making it look a bit like a degree symbol, just like that. All right, so the data has been properly managed. The next thing that we need to do, step 2, is the formula. Each of these degrees Celsius temperatures needs to be converted to Fahrenheit using the formula that you see I've written above. Fahrenheit can be calculated by multiplying Celsius by 1.8 and then adding 32. We can do this calculation efficiently in Excel. First, click in the cell just to the right of the first temperature that you're going to convert. Press equals. Equals tells Excel that this is going to be a calculation and not just some miscellaneous text. Then 1.8, of course. Multiply is the asterisk. Now, the Celsius temperature is located in cell B7, and so we type in the coordinate B7, which then highlights cell B7 and tells us that we've entered that coordinate properly. Excel will take this 38.251 and convert it into Fahrenheit degrees in just a moment. The last thing is to add 32 and hit enter. There is the Fahrenheit temperature conversion performed correctly. Now what we'll do is we'll very quickly copy that equation that we've written into all of the other cells below, converting all of the Celsius into Fahrenheit. We do that by clicking on the cell again, locating the small handle, the little black dot in the lower right-hand corner of that cell, obtaining that cursor, clicking and dragging down to the very end of the data table, and releasing. All of the temperatures that were previously Celsius degrees now in this third column have been converted to Fahrenheit very quickly, very efficiently. We finished with step 2. The next step 3 is to create a graph. To create a graph, we need to select 2 different columns. The convention used in Excel is that the left-hand column will be X values and the right-hand column will be Y values. I've arranged my data to be correct. I was hoping that to graph temperature on the y-axis and X would be the time axis. Knowing that ahead of time, I put the columns in the way they should be. In any case, we take only the numerical values from those columns and highlight them, clicking and dragging appropriately. I'll scroll back up to the top, which is where I would like to put the graph. Click on Insert. Choose the Scatter Plot option. No other option will do. It must be the Scatter Plot, and I'll choose to connect the dots. As you can see, the graph now is a graph of temperature versus time. However, the degrees or the temperature is measured in degrees Celsius, not in degrees Fahrenheit, and that's something we need to change. Let me show you how to do that. If I click outside the graph, just to clear any settings or things that we might be looking at, and then click on the graph again, you should notice that the 2 columns for time and temperature are highlighted, and this is a nice feature because it tells us what columns the graph is referring to. Now, we would like to redirect the Excel graph to look at the temperature in Fahrenheit degrees, which can be easily done. I'll take my cursor now, move it over to the blue column, positioning the cursor just on the border. Clicking and dragging, I can move that column over to the right, 1 column, and now, when I release, I have a graph of temperature in Fahrenheit versus time in seconds. This is the way, for this particular assignment, the graph should be constructed. As we have created the graph now, we need to talk about, we've changed the columns, we need to talk about formatting the axis. In this case, we have a lot of empty space in the graph in this area right here. We always try to display the data as fully and occupying as much space as possible. We'd like to eliminate the data right here. You can see that from 0 all the way up to 60, or maybe 50, is empty and blank. We could make better use of that space, and here's how you can do that. I'm going to right-click on the numbers corresponding to the y-axis. I'm going to format that axis, whereupon a window opens up, and I'm going to change the minimum value, which is currently 0, to 50. Clicking in another cell in that window shows me the new graph now, which I can close, and now you can see that the data more completely fills the graphing space. This is a much better use of the graphing space than was previously. Okay, so we formatted the axis just fine. Now what we need to do is we need to add titles. Now the Excel defaults and produces a little space up here called Chart Title, which we can click in, and we can replace with the actual title to this graph, which is going to be temperature. And those are in units of degrees Fahrenheit versus time in seconds. I'll hit an enter to create a secondary title and enter my name. Obviously, enter your name. Happens to be the 25th of January, just like that. Now, we can clean this up and make it look more professional. I like to boldface the primary title. Let's fix that degree symbol. And I also like to put the secondary title into a slightly smaller font. It's a more professional appearance, and professionalism is what it's all about. The next set of titles that we need to take care of are those that would label the axes. The X and Y axes need to be labeled time and temperature respectively. If you're working with a PC, you can click on this plus sign over here and you will have the opportunity to add the axes titles. If you're working on a Mac, you may have to dig a little bit deeper to find a place where you can add the axes titles. I'll go this route for this demonstration. Let's enter in the primary horizontal axis title, creating a box called the axis title and replacing it with time, also remembering that the units should be included. My x-axis title looking good. Next thing, I'll add another element, the primary vertical, and that needs to be temperature, spelled correctly, and the units should be degrees Fahrenheit. And while I'm at it, I'll highlight that, right-click, and change it into a superscript, just like that. So far, so good. Graph is looking pretty nice and pretty professional. There's one thing that we do need to add to the graph for this particular assignment, and we'll do that. It's not in the list at the right. We'll do that here by adding several text boxes to label the regions of the graph that are of interest to us. So I've clicked on the graph. I go to the Insert menu, look for text, and then find Text Box. Drag a text box in this region right here and label it as Region 1, Water, Cooling. Okay. Then go ahead and insert another text box into this region right here. And we'll enter Region 3, Water, Warming. And a third text box for where the ice is actually melting. So that'll be right here, and we'll go Region 3, Ice Melting. Now those text boxes can be moved and repositioned if you're not happy with where they're located, but I've done a pretty good job of locating the text boxes exactly where they should be. I think it's clear that they are describing these regions as just where they are. Okay, so having done that, we formatted the axis, we've added the titles and the text boxes. Now what we need to do is identify subsets within the data. We're particularly interested in Region 1 and Region 3, and we need to highlight those regions so that we can perform an analysis on those regions. And this is how we go about doing that. I'm going to take my cursor and hover over the first point, and when I do so, the point lights up, and it's pretty clear that on the left-hand side of my graph anyway is 0, and I'm actually centered right now on point number 2. So this region right there is defined as beginning when time is equal to 2 seconds. I also need to identify the end of region 3, which, good enough, is 119. I'll bet it's closer to 120. So we've got these two numbers that define the range of region 1. We need to know those in advance. Furthermore, we need to know the same region or the same numbers for region 3. Region 3, I'll pick a point right here. I don't want to pick a point anywhere on the curve. That point right there, if it will light up for me, that'll do, is point 169. And I end at point 300. Good. So these numbers define the beginnings and endings of regions 1 and regions 3. Knowing this, I'm going to create a data subset. Okay? And the way I do that is I go within the graph and right-click. And then I say Select Data. Selecting data is a way of creating a new, smaller subset of data to look at. I click Add in the window that opens. In the series name box, I type in Region 1, because that's the region I'm going to be working with. Now, the X values and Y values have to be entered using the Select Range arrow. I'm going to select the X values for Region 1. Recall that the X values for Region 1 ranged from 2, let me scoot over just a little bit further, from 2 all the way up to 120. So I'll scroll down, whoops, a little bit too far. Fix that, there's 120, and then I click the down arrow, and that range has been entered. The next thing is to enter the corresponding Y values. Clicking on the Y value arrow, click, scrolling to the top, I'll need to begin where time was equal to 2, but I need the temperature values, and don't forget these need to be the temperature values in Fahrenheit, all the way down to 120. Okay, so I have now selected the time from 2 to 120 and the corresponding Fahrenheit temperatures from 2 to 120. Click on OK. Done. While I'm at it, I'm going to add another series, and we're going to call this series Region 3. I'll need to click to identify the data for that particular range, and so I'm going to click on the arrow telling Excel that I'm going to be collecting data. I'm going to scroll to the top here. Notice the graph now has a highlighted red region. That is the result of the first data subset that we created. This next data subset needs to start at 169 and continue through 300. So 169 is right about there. And I'm going to go from 169 down to the very end, which is 300, clicking on the arrow to accept that range, and now doing the very same thing for the corresponding 169, but grabbing the Fahrenheit temperatures instead all the way to the end. So very important that we have to match these regions, but select the correct columns. Click OK and click OK, scroll to the top, and now you can see that we have two regions that are highlighted in a different color, one for Region 1 and one for Region 2. This is important because we're going to tell Excel in just a minute to analyze those specific regions with a trendline analysis. Let's see where we are. We formatted the axis, we've completed the titles, and now we've finished up with the data subsets. The next step is to create trend lines. Trend lines are lines that the computer draws through your data as best as possible. We can create a trend line by positioning the cursor over the first set of data that we have now created as a subset, right-clicking, and adding a trend line. The window that pops up defaults to the linear trend line, which is just fine. Scroll through that window and make sure that you click on the checkboxes Display Equation and Display R-squared value, and then you can accept that. The equation has been included on your graph. However, we'd like to increase the number of digits that are displayed in that equation. I will right-click on that equation box, format the trend line label, look for the number formatting, and increase the number of decimal places to something crazy like 8. If you're using a Mac, this may or may not work. Just in any case, try to display as many decimal places as you possibly can. Having done that, we can then click outside and see the trend line in all of its glory. This is an equation that's of the form y is equal to mx plus b. In this case, the slope is a negative 0.0179956. And the y-intercept of that line is 100.539. Okay, now the other thing that would be useful here would be to show the line. And I'm not seeing a way to do that. I think we'll just probably go with that the way it is and move on to region 3. Region 3, same recipe, right-click, add trend line, display the equation on the chart and the R-squared value. Okay. You can click out of that. Now that we have an equation, let's reposition it in a little bit better place. Right-click, format trend line label, go to the number, and increase the number of decimal places to 8. And now we have the trend line equation for that section of data highlighted in green. Again, an equation in the form of y equals mx plus b. Notice that the first equation has a negative slope and the second equation has a positive slope. This tells us about whether they are pointing upwards or downwards. Okay, we've accomplished a great deal. We've created data subsets and trend lines, and we've done the trend line equations and reformatted them. This is a graph that is fit for a report. So as far as the way that I'm going to put this into my report, I'm going to click outside it just to get a nice clean picture of that graph. And then I'm going to use my keyboard by pressing Control and Print Screen, which I will need to go to a different keyboard for. One moment, please. Wait for it. Okay. Control Print Screen has now copied a screenshot of the entire picture from the screen ready to paste into my lab report. So let me do that. I need to go out and get the lab report, which is something you've probably already done. I'll go to the laboratory website and download a copy of this lab report, Computer Survival. Click, open it up, and enable editing. Okay, so this is the report that you're going to be putting together. And note at the bottom it says include your graph as a last page for this report. So I'm going to click in that region at the very end of the document and move on to the next page and paste the screenshot. Now, as you can see, the screenshot includes a lot more than just the graph. Okay, and we'd like to eliminate that. The process of zeroing in on just the graph and eliminating everything else is called cropping an image, something that you already may be familiar with. In any case, to create that graph in my report so that it looks good and it's positioned properly, we're going to click on that image, go to Picture Format, click on the Crop tool, and drag these little handles in ways that allow me to select only the graph and eliminate all of the other extraneous material. Clicking outside, now you can see the graph is nicely trimmed away from all of the other things. At this point then, I can resize it and have it fill the lab report in a very professional way. So there you go. All the way from experimental data to graphing and trend lines to finally pasting the graph into your report. Hope this has been helpful.